In this lesson, we are going to learn how to write a polynomial function when you're given some zeros. So in this first example, it says to write a polynomial function of minimum degree in standard form with real coefficients whose zeros include the given numbers. So we are told that our zeros are 3 and -5. So of minimum degree would mean that, so this has two zeros that we can see because they are real, therefore it would be quadratic. So a parabola that would cross at 3 and -5 would be one of least degree. Now there potentially could be a function of higher degree that has additional zeros, but we're going to do the one that just has these two. So if the zeros are x equals 3 and -5, the corresponding factors, let me erase this, corresponding factors would be x minus 3 and x plus 5. And since I'm making this a function, I'm going to say f of x equals this. So I start by writing my factors, and now to put it in standard form, I'm going to distribute. So that's going to give me x squared plus 5x minus 3x minus 15. I will combine my like terms to get the function x squared plus 2x minus 15. Now, this is not the only polynomial function that fits these given conditions. If I multiplied by any constant, like if I multiplied this all by 2, 2x squared plus 4x minus 30 is another polynomial function, and there's really an infinite more, but this is probably the simplest one that we can create. So in the next example, I can see that I'm given 3 roots as a starting point. So 4 and then plus or minus root 3. So I'm going to say that g of x is equal to, so my first factor would be x minus 4, and then I would have x plus root 3 and x minus root 3. So I can, to put this in standard form, multiply any two together. To make your life easiest, always do these two here together first that just have the opposite signs. Because what happens when you do that, you get x squared minus root 3x, and then you have plus root 3x, and then minus root 3 times root 3 is just minus 3. What happens is these two middle terms drop out. So you get just x squared minus 3, and I'm going to bring down this x minus 4. You know, you start to do enough of this multiplication and you see some patterns, and some learners can jump right from this line down to this line here. All right, now again I'm going to distribute, and when I do, I'm going to get x cubed minus 3x, and then minus 4x squared plus 12. To put this into standard form, I will restructure this, making this, oops, and I just realized this should have been 4x squared right there. Making this x cubed minus 4x squared minus 3x plus 12. It's a good idea to throw that in your graph calculator and make sure that it has the 3 given zeros. In our third example, we encounter a complex zero. So we're told that -I is a zero. Well, by the complex conjugate theorem, you need to know that I is also a zero. They come in pairs. This would give me h of x is equal to x plus 1. Now, this 1/2, rather than writing x minus 1/2, I'm going to write 2x minus 1. And off on the side here, I'm going to show you why that is. So if the 0 is x equals 1/2, to get the factor, if I multiply both sides by 2, I would get 2x equals 1, and then subtract 1 from each side, I get 2x minus 1 is equal to 0. So the factor is 2x minus 1. And then my complex zeros would be x plus I and x minus I. I'm going to begin by multiplying the x plus I and x minus I together, and you see this a couple of times and you start to see a pattern here. So again, these are multiplying conjugates together, so my middle terms are going to drop out. So I would have x squared, I would have plus ix and minus ix. So I'm just going to get rid of this right away. Believe me, when you multiply conjugates together, again, those middle terms will always drop out. So I'm just going to have minus I squared. And remember what I squared is. It's -1. So if I have minus -1, what this actually is x squared plus 1. Right? So multiplying x plus I times x minus I produces x squared plus 1. And I am going to multiply these two together. So that would give me 2x squared minus x plus 2x minus 1. I'll combine those like terms to get 2x squared plus x minus 1, a trinomial, and then I have times x squared plus 1. So to get this in standard form yet, I have to multiply a trinomial times a binomial, so that's 6 multiplications I need to make. So I begin by, I like to distribute the smaller into the larger. So I'm going to take x squared times 2x squared and get 2x to the 4th. X squared times x would be plus x cubed minus x squared. Then I distribute this positive 1 into all 3 terms here to get plus 2x squared plus x minus 1. So now I just need to combine all my like terms to get h of x is equal to 2x to the 4th plus x cubed plus x squared plus x minus 1. So here is a polynomial function in least degree that fits our given conditions. Take a second and throw this in the graphing calculator and make sure it matches our given information. So on the screen you now see a graph of the function. I just tossed this into Desmos. You can see that it has a 0 at -1 at 1/2. And you can't see the negative I and I. It almost looks like a parabola, but it's not, because look at this, like it's got this little weird asymmetrical dip happening right in here. And that's because we've got these 2 complex zeros. In our final example, you have a complex 0 of 2 plus 5i. So you should know by the complex conjugate that there is also a 0 at 2 minus 5i. So we are going to begin by writing down our zeros. Well, we have our zeros, I mean to say our factors, x plus 2. We have one at just 0, so I'm going to squeeze in an x out front. I'm not going to write x plus 0. And then I have x minus 2 plus 5i. And I have x minus, the second one, 2 minus 5i. Okay, so I'm going to begin by focusing on this part right here. We'll look at how to clean this up a little bit. So I'm going to distribute this minus here. So this would be x minus 2 minus 5i. And over here I have x minus 2 plus 5i. So let's look at a faster way to multiply this. I could do a lot of distributing and have 9 multiplications to make and then start combining like terms, and there's no shame in that, but I noticed that if you look at it like this, x minus 2 is the same. So x minus 2 minus 5i and x minus 2 plus 5i, that's going to fit the following pattern. I'm going to show you in a side note over here on the side. That's like having a minus 5i, so I'm saying let a equal the x minus 2 times a plus 5i. Again, when I multiply conjugates together, what happens is my middle terms drop out. So I have a squared, I would have minus 5a and plus 5ia, and they would cancel. And then I'd get minus 5i times 5i would be minus 25i squared, which would produce a squared plus 25. Okay, so this is the same thing over here on the left. If I say x minus 2 is at a, I'm going to get a squared plus 25. So now all I have to do is figure out, okay, so what is my a squared? That would be x minus 2 times x minus 2. Which would be x squared minus 4x plus 4. And then I have the plus 25 on the end. Since I'm saying that this is a squared, So I would combine the 4 and the 25. So this is going to become x squared minus 4x plus 29. All right, so let's go back over and finish the rest of it. I can distribute this x to get a binomial of x squared plus 2x. So a lot of multiplication, but it's really not all that bad. So I have a binomial times a trinomial yet, so I've got 6 more multiplications to make. I'm going to begin by distributing this x squared. So I get x to the 4th minus 4x cubed plus 29x squared. And then I add distribute the 2x, so plus 2x, this one here, 2x cubed minus 8x squared plus 58x. And now, final, combine everything to get x to the 4th. I have a negative 4x cubed and a positive 2x cubed would be negative 2x cubed. Combine my x squared, so 29x squared minus 8x squared would be 21x squared plus 58x. So I get a quartic function. I encourage you again, put this into your graphing calculator and make sure that your given zeros are shown.